For our third section in this chapter, we're going to be discussing the sum of an arithmetic sequence. Within this section, we're going to need to use a formula for the arithmetic sequence because we're going to need to identify certain elements in order to evaluate our sum. Let's get started. To begin with, we have the formula for the sum of an arithmetic sequence, and that is S sub n, or the sum, is equal to n over 2 times a1 plus an. So within our formula, again, S sub n is going to represent the sum. Usually that's what we're trying to find, but sometimes it's given to us. N is always going to be the number of terms that we have, or how many terms we're adding up together. A1 is our first term, and then A sub n is our last term. Term. So in order to find the sum, we need to know all of this information. If it's not given to us, then we have to find it. And we're going to find it by using the formula for an arithmetic sequence, the thing that we talked about in the last section. Let's go ahead and look at some examples here. For our first problem here, we could very quickly add all these numbers together and get our sum. And if you did that, then you would figure out that the total is 275. We're going to verify that our sum formula works, hopefully getting that same number. To begin with, we're going to identify what we know. So n is the number of terms we have, and if you count up all the terms we have here, then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, 10 numbers means n is going to be 10. A sub 1 is always our first term, which in this case is the 5. And A sub n is our last term, which in this case is 50. So to find the sum of the 10 terms, then for a formula we have 10 over 2 times 5 plus 50. Oops, forgot to put 50 there. Alright, so that's going to simplify to be 5 times 55, which does in fact turn out to be 275. So here we can see that our formula works. And again, if we only had 10 terms to add up, we wouldn't need the formula. But sometimes we're adding up 100 terms or 1,000 terms, and the more terms you add up, the more you're going to want to use this formula. Let's look at another example. For this example, we have Lucky Larry, and he's finally changed his betting luck. He's actually winning. So we have scores for his first and 100th bet. We want to know how much he won in total. Looking at the information, we know that for his first bet he won $15. For his last bet, he won $307, and then we know that he made 100 bets. So when you plug in your information, again, the first term goes in for A1, the last term goes in for AN, and then we know he made 100 bets, so that's going to go in for RN, which will give us our formula. So we have S100, or the sum of the first 100 bets, is equal to 100 over 2 times 15 plus 37. When we simplify all of that, we get that the sum of the first 100 bets is equal to 50 times 322, or that Lucky Larry won $16,100. So he's a pretty good gambler. For this example, we're not going to be given all the information that we need. So to begin with, n is going to be how many terms we have, and we're trying to find the 50th partial sum, which means we're going to have 50 terms. A sub 1 is equal to negative 6, and A sub n is equal to the 50th term, which we don't know. Anytime that we don't know something for our sum formula, we have to resort back to using our formula for an arithmetic sequence, which is A sub n is equal to d times n plus c. Using this formula, we could then find the 50th term and solve for our sum. So for our formula, A sub n is going to equal d, which is our common difference, and to go from negative 6 to negative 2, we're going to be adding 4. And then for c, remember it's always a1 minus d. So in this case, c is going to be negative 6 minus 4, which gives us negative 10. So using that formula, I can find my 50th term by plugging in 50 for n. And I get 190. So 190 is now my a sub n on my last term. To finish solving for my sum of the first 50 terms, I'm going to plug in all of this information, and we get that it's equal to 50 over 2 times negative 6 plus 190. And that simplifies to be 4,600. So again, just to recap, we didn't know one of our pieces of information that we needed to find the sum. So in order to find that piece of information, we have to use our formula for arithmetic sequence to find what's missing. We're going to look at how this is done a little differently. So here we're given some of the terms for an arithmetic sequence, and we can verify it's arithmetic because we have a common difference of adding 7 every time. We're also asked to find the sum, so we're going to label what we know. The first term of our sequence, a sub 1, is equal to negative 6. The last term of the sequence, a sub n, is equal to 141. And we don't know. So again, whenever we're trying to find one of our 3 pieces of information that we don't know, we're going to resort to using the arithmetic sequence formula we learned from the last video. So we have 3 steps here. The first step is to find our arithmetic sequence. So to find our arithmetic sequence, we need to identify the common difference, which we said was 7. We need to find a sub 1, which is negative 6, and then use that to help us find c. So again, c is equal to a1 minus d, in this case negative 6 minus 7, which gives us our negative 13. So now I have the formula for our arithmetic sequence. I know the first and the last term, so what I don't know is n. Step 2 is to use our formula to find what we don't know. So in order to do that, we're going to take our formula and we're going to plug in the last term for a sub n. And we can see that we now have 141 is equal to 7n minus 13. I can then use this equation to solve for n, and when we do, we get 22, which means that there are 22 numbers in our sequence. Now that we have found our formula and use it to find the missing information, we now can go into our sum formula to find the sum of the sequence. So we would plug in 22 for n, negative 6 for a1, and 141 for a sub n, and simplify to get that the sum of this sequence is 1485. So again, our plan of attack is in 3 steps. Initially, we want to make sure that we have all the information, and when we know that we're missing something, step 1 would then be to find the formula for the arithmetic sequence. Step 2 would be to plug in what we know to find what we need. In this case, we needed to find n. And step 3 would be then to plug everything into our arithmetic sum formula to find the sum of the sequence. This concludes our notes for this lesson. Tomorrow in class, you're going to be applying what you learned today to try and find the sum of various sequences. And again, make sure that you watch out for the problems when you're missing information and you have to find something. Good luck.